the either FIFO, the round robin, and the others, and there is the shortest remaining time. But this is more like a round robin, but uses the concept of short jobs first. But now it is a preemptive version of short jobs first. But we'll be having time. You can have your own time to go through it. It's showing you how to calculate the average turnaround time. It's also showing you how to calculate the average waiting time in a very, very simplified way. So if you follow it, it will be very easy to answer that question without trouble. Because shortest job next is a preemptive scheduling algorithm. So I want us to go to question 6 of this, and maybe we'll spare time. You'll spare time at your convenient environment to go through that YouTube. So let's go through the next question. The next question was asking about what? The next question was outline 4 technical factors that consider before installing an operating system. 4 technical factors. Or what are the factors to consider when you're installing an operating system? Yes? Somebody to answer? What are the factors to consider? Let's move fast so that we're able to get value for our time and data.
One, we have compatibility.
Yes, you have to think about the aspect of compatibility. Yes, we are talking about technical factors. The question is very categorical. What are the technical factors to consider? And I think we had talked about this some times back, the factors to consider when you're installing an operating, or when you're choosing an operating system. You remember? But now they're asking you technical factors to consider before installing an operating system. Of course, you have to consider the memory, the size of your memory, the size of your hard disk, the processor, and even the computer architecture. Because at times you may be going for a very high operating system, yet your hardware cannot be able to support. Like for example, you want to install Windows 10 in your mobile phone. The technical specifications of your phone cannot be able to allow you to install such kind of an operating system on such a small device. So it's important to consider those technical factors. What hard disk storage do you have? What is your memory capacity? What is your processor speed? Yeah, what is the architecture of your computer? So it's very important to consider those four factors: the memory size, the hard disk size, the processor, and the architecture of your computer. Those are technical factors, and mostly they are the hardware factors that you have to consider. Okay, the next question was asking about what? No, at the moment I'm not sharing the screen. We're just going through the question papers. I don't know whether I had them. Let me see whether I have the question somewhere. Then I can share the question so that we're able to see them. So the next question was asking, I'm just going through the phone, differentiate between a single task and multitasking operating system. I believe this is a question that we know. Yeah, I don't know whether I have the papers here. The November. So there was this other question asking about differentiate between a single tasking and multitasking operating system. What is the difference between the two? What's the difference between single tasking and multitasking?
Single task perform one job at a time, while
yes,
multitasking performs 2 or more jobs at a time.
Yes, that is true. So that is the big difference between a single tasking and a multitasking operating system. Now the next question was asking about what? The efficiency of a system using round robin job scheduling scheme is dependent on the size of time slice. Explain one positive and one negative effect of short time slice. You remember when you were talking about round robin at the beginning of the first term, we said that when you're doing round robin, you're basically giving a time slice to processes. Where we're saying that, for example, you have maybe 3 processes, process A, B, C. So with round robin, you give a process. If you say you're going to give it 2 microseconds, it will be 2 microseconds. So process A will be given 2 microseconds, and then process B 2 microseconds, and then process C 2 microseconds. And then you go back to A if it did not finish with the 2 microseconds. So you keep on giving these processes time until all the processes are complete. Now, what are the challenges, or what is one positive and one negative of giving short time slices? Like, for example, you're going to an office and somebody says, I'm giving you 2 minutes. If you not have finished, you go at the end of the queue. So even before you explain your problem, 2 minutes are over, you go out. Now, one of the positive factors of short time slice is that the waiting time of processes is minimal. The waiting time will be minimal because we are saying that every 2 seconds, 2 seconds, 2 seconds, 2 seconds, a process comes in and leaves. 2 seconds, another process. 2 seconds, after 2 seconds, another process. So the waiting time is minimal. But the negative effect of this is that there is more time is spent swapping in and swapping out processes, making it inefficient. So when you give processes short time slice, you make your system inefficient because you're spending more time suspending processes. So we are saying when you give processes a short time slice, it becomes a disadvantage because the system spends more time swapping in and swapping out processes. But the advantage is the waiting time is minimal, and that becomes one of the greatest advantage of round robin. Now let's go to the next question. Explain 2 file allocation method used by operating system. I think this is in our notes. File allocation methods. What are the 2 file allocation methods?
One, we have contiguous.
Yes, there's one contiguous, yes. We have what you call linked allocation. We have index. There are many methods, and I think we discussed about them. But you'll find that the 3 main that you'll find is contiguous, we have linked, and indexed. And I think we have them during our last topic that we discussed. They were at the bottom of the page. And I believe we went through them. Yeah. The next question was asking about file system employ various blocking strategies in order to provide effective storage of file. Explain 2 such strategies implemented by operating system. Blocking strategies, yes? Anyone who've gone through them? These are blocking strategies that they are saying file system employ various blocking strategies in order to provide effective storage of files. Explain 2 such strategies implemented by operating system. You remember we talked about file. I don't know whether I'm confusing. We talked about just a moment. I think I may be giving you the wrong answer because I thought of you can block a file or you can block a record. Let me just check here. Just 1 minute. I see. Yeah, I think there should be the 2 where you can block a file or you can block a particular record. Yeah. Let me check whether I could be having a different alternative for that. So that was question 7. Question 6D. Yeah. Okay. Those are the two methods that you can employ to implement that. The next question was asking about what? Explain the following terms as used in operating system. I think we talked about an interrupt. Is an external request to the. It's an external request from a process to the processor, requesting it to suspend the current process and handle a different process. A system call. We have it in our notes. What is a system call? It is a.
These are the requests made by any program to the operating system to perform a specific task.
That is very true. It's a request by a process to the operating system to perform a specific task. Yeah. The question 7B was saying Jesse has realized that all the active tasks on his computer system are deadlocked. What are the approaches he could employ to recover from this situation? You remember we have the approaches to what are the approaches you could employ to recover? You remember when you're talking about deadlock recovery strategies, what are they? Very fast, I believe we have them in our notes. What are the deadlock recovery strategies? One of them will be what? You can abort all the deadlocked processes. That is one of the methods to recover from the deadlock. What is the other method? You can roll back processes, where we are saying that you identify the resources that are needed, and then once you identify the resources that are needed, then you start taking away those processes. Again, you can kill processes, where you're saying that you can decide to kill a process at a time. If you have 4 processes that are in a deadlock, you decide that I'm killing process A, and then maybe decide to kill process D. So you can recover from a deadlock either using preemption, you can recover using rollback, you can recover through killing processes. Yeah, so those are the ways you can recover from a deadlock. And I believe we all know what is preemption. You take away the resources that are held by a process. Yeah, but when you talk about rollback, you identify which resources are needed. And then once you identify the resources are needed, then the process that is holding that resource, the process that owns a needed resource is rolled back to a point in time before it acquired the same resource. That is rolling back. Rolling back is like pushing the process to a time before the deadlock occurred. And then those resources now are available to other process. That's what you're calling rolling back. It's more like pushing the process, a particular process, to a point where there was no deadlock. And then the resources that were taken and a deadlock occurred, then the resources are now available to other processes. When it comes to what you call killing of processes, it means that you terminate specific processes. But the challenge of terminating these particular processes will be you will have wasted the time of execution, because maybe the process is only waiting for remaining with maybe two microseconds to finish, but you decide to kill that process. You're terminating that process, yet it was almost in the process of completing. But for the purposes of recovering from deadlock, then definitely you have to kill that particular process. Now, the next question was asking about, that is question C, outline 4 free space management technique used in file management. What are the free space management techniques that we know?
Linked list.
Sorry?
Linked list.
Free space management. You're talking about linked list. I can't hear you.
Yes.
Okay, I have linked list.
List.
Yes, that is true. Linked list. They're asking about 4, yeah? Yes, we have linked list. Another method, free space management techniques. Maybe I can just list them and then maybe you will have time to go through them. We have bit tables. We have chained free portions, sorry. Maybe I read them slowly and then you can have time to go through them. We have bit table. And please note that the question was talking about what? Outlining 4 free space management techniques. We have bit tables, chained free portions, we have indexing, and we have free block lists. Those are the 4 methods that we can employ to manage our free space. We have bit tables, we have chained free portions, we have indexing, and we have free block lists. Are we together? So those are the 3 methods that you can employ in the management of your free space. The other question was asking about file system employ various blocking strategies. No, sorry. The cleaning policy ensure. Let me highlight the question here on the screen. The file system employ various. The cleaning policy ensure modified pages are removed to create spaces for others. With an aid of an example, explain 2 such policies used by operating system. Cleaning policy ensures modified pages are removed. Cleaning policy ensures that modified pages are removed to create space for others. With an aid of an example, explain 2 such policies used in the system. I think somebody had asked this question sometimes back, yeah, during our class, and we have what we call demand cleaning, where a page is written out to secondary memory only when it has been selected for replacement. Demand cleaning. A page is written out or it is removed from memory to secondary memory only when it has been selected for replacement. That is what we call demand cleaning. Now we have what we call the pre-cleaning. And we are saying that in this policy, you writes modified pre-cleaning. Policy writes modified pages before their page frames are needed. Those are the two methods that you can employ to do cleaning policy. You can do demand cleaning, where you're writing out pages to secondary memory only when those pages have been selected for replacement. And then you have what you call pre-cleaning. This policy writes modified pages before their page frames are needed. Those are the two methods that you can employ when you're dealing with cleaning policy. Now, when you look at them, it's basically a mechanism of making sure that our memory is not overloaded with unnecessary stuff. And that is why they are asking about what cleaning policy. Ensure modified pages are removed you're creating more space to your memory. So you're told with an example, so you have to explain the two very well. But I think there was a challenge of 6 marks. Of course, it is 3-3. So meaning when you state, maybe it's 2 marks. When you explain is a mark. So those are the two methods that you can employ. We have question 8. Question 8, let me just push this up. Outline 4 objectives of file system as applied in operating system. What are the objectives of file system? Objectives of file system.
One, we have concurrency.
Yes. Objectives of file system. One of them was to meet the data management needs and requirement of the user. That was one of the objectives. Yeah. Number 2 is to guarantee valid data in the file. We also talked about the aspect of, was it optimizing performance? Yes, optimizing performance. You also make sure that your data is not lost or even destroyed. That's why you must have a good filing system. And also provide IO support for different storage. And I think those we discussed about them sometimes back. Now, the other question was asking about, with the aid of a diagram, outline the organization of input-output subsystem. Input-output subsystem, yeah? How do you organize an input-output subsystem? IO subsystem. If you have columns with different rows, a table. One of them, at the top, you'll have the cache manager, you'll have the file system driver, you'll have the network driver, and you have what you call the hardware device drivers. See the cache manager, the first one. If you draw a table with only one column, the first cell will be cache manager, the second will be file system driver, the other one will be network driver, and the other one will be hardware device driver. Are we together? So when you're outlining the organization of IO subsystem, the first cell you will have the cache manager. The second you will have the file system drivers. The other one you will have the network driver. Finally, you will have what you call the hardware device drivers. Those four are the organization that you're supposed to have for the IO subsystem. I hope you have noted them quite well. The other question was asking, memory segmentation is an important concept in memory management. Explain 2 ways of implementing this concept by operating system. Memory segmentation is an important concept. Memory segmentation is an important concept in memory management. Explain 2 ways of implementing this. One of them, you can do segmentation without paging, and you can do segmentation with paging. Now, when you do segmentation without paging, you're saying requires that the entire segment be swapped back and forth between main memory and secondary storage. Let me explain it well. When you're talking about segmentation without paging, you remember when you're talking about paging, and we said that in paging, you're dividing the process into pages, and the memory into frames. Now, when you do that, it will mean that you will be bringing processes in memory on demand. But now when you look at the aspect of segmentation without paging, it will mean you move individual pages back and forth between memory and secondary memory. But when you do without swapping, it will mean you're bringing the entire process into memory. And once you're through, you swap it out. So we're saying segmentation without paging requires that the entire segment be swapped back and forth between main memory and secondary memory. But when you're dealing with segmentation with paging, you're only moving individual pages back and forth. But without paging, you're moving the entire segment back and forth. So when you do segmentation with paging, there is better utilization of memory, because you're only bringing in pages that are needed. But with segmentation without paging, you're bringing the entire segment into the main memory. You're bringing the entire segment into the main memory without leaving any into the secondary memory. That's very important. So I hope you're getting the differences between the two. So when you do segmentation without paging, it will mean you're not breaking the process into pages. So you're bringing in the entire process into the main memory, the whole program or the whole process into the main memory. But when you do segmentation with paging, you're breaking the process into pages, and you're only bringing into the main memory the pages that are required for execution. And that means there is better utilization of the main memory. Now, the last question for the last question for this was asking about what? Walter would like to design an operating system for multi-level process scheduling system. Explain 3 parameters he should consider to guarantee efficiency in the system. 3 parameters that he should consider to guarantee efficiency. Parameters for multi-level process scheduling algorithm. Now, if I was to go to our notes, let me just check. I can be able to have them. When you're dealing with multi-level queue, we talked about 2 types of multi-level queue. Let me stop sharing this. I shared these notes, operating system. Now, when you look at the notes that we shared, I don't know whether you're seeing the notes that I'm rolling. We talked about the 2 types of multi-level. We talked about multi-level queue with feedback, and we talked about multi-level queue scheduling. Here they are asking 3 parameters I should consider when you're dealing with multi-level process scheduling. Multi-level. Different processes are assigned to different queues. That's what we discussed when you're talking about the multi-level queue and also multi-level queue with feedback. The only difference between the two is that with multi-level queue with feedback, when you're discussing, is that processes can move between queues. But with multi-level queue scheduling, processes stick to their queue. The processes will stick to their queue. Now, the question is asking here 3 parameters you should consider to guarantee efficiency in this kind of multi-level queue. Now, one of them is the number of queues. How many queues do you want for your multi-level process scheduling system? That is number 1, the number of queues. Number 2 is scheduling algorithm for each queue. Scheduling algorithm for each queue. Number 1 is the number of queues. Because if you look at this, for example, the one I'm displaying on the screen with multi-level queue without feedback, you're saying we'll have a queue for system processes. You will have a queue for interactive running. You will have another queue for interactive editing. We'll have another queue for batch processes. You will have another queue for student processes. So you're saying that you decide how many queues do you want to have. If you want many queues, fine, but you must be very objective. So one of them is the number of queues. Again, what scheduling algorithm for each queue? For example, you could be having these, for the student processes, it is fast in, fast out. But for system processes, it can be priority scheduling so that higher priority processes are allowed into the system earlier. For the interactive running, maybe you can do what you call round robin, where you're giving each process a time slice. That is what we call interactive running, so that a certain user and another user are accorded a specified amount of time. Number 3, we'll also need a method used to determine when to upgrade or demote a process. What methods will you use to promote or demote, or what you call to upgrade or demote a process? You must have a mechanism to determine. And finally, you may have to think about the method to determine which queue a process will enter, so that system processes will have go to the system. Processes that require interactive application, you have to decide which process will go to which queue. So when you're deciding the number of queue, you must also be considering which processes go to which. Very important. So those are the 4 parameters you should consider when you're dealing with the multi-level process scheduling. I hope you have noted them well, because you're likely to find these questions again coming on board anytime. So it's important you remember these low-level scheduling that we discussed in our first term. They are quite popular. They start from here. Low-level scheduling algorithm: short jobs, fast come, fast serve, round robin, shortest remaining time, highest response ratio, and multi-level queue. They are very, very important. Are we together, ladies and gentlemen? Are we together?
Yes, we are together.
Yes. Now that was the paper that was for 20. That was 20 what? 2019. 2019 November. I think so. Any query? Can we agree now on which paper to go to? You can contribute now. You just unmute and raise your request or your comment. Yes, I have the July 2018 with me. I don't know whether it's going to be visible. Computer processes can be either CPU bound or IO bound. Let me see, July 2018. Let me see whether I can share them in the WhatsApp. 1 minute. Let me see. Now I've just sent them to your WhatsApp. Yes, we can start this, and then God willing, I should be looking for the other class. Let me just open them and share. So this is 1921-06 for the operating system. I don't know whether it is visible from your end. Is it visible? It's not a very good resolution, because it was, I just picked it from, have you seen it? Now explain to process, the computer process can either be CPU bound or IO bound. Explain one advantage of each of the other mode of operation. You see those questions? Are you able to see that question? Is it legible? Or I look for the paper again and then we spend time on it. Are you able to hear me? Okay, that's fine. It's good. Now, if you look at the paper that we are talking about, what are the advantages of CPU bound? When you talk about CPU bound, what are we talking about? CPU bound processes spend more time using the CPU. IO bound spend more time using the input and output device. Explain one disadvantage of each of the modes of operation. Now, one of the disadvantages of CPU bound processes is that they spend more time doing computation, but long CPU burst. They spend more time doing computation. That is for CPU bound. But for the IO bound, spend more time in. Let me repeat the first one. The CPU bound spend more time doing computation, few but long CPU bursts, but they end up underutilizing what? The input and output devices. Now, the opposite happens to the I/O bound, where the CPU spends more time using, where the input output or the I/O bound, they spend more time using the input and output devices and short time using the CPU. So with the I/O bound, more time is spent on input and output device, while the CPU is underutilized. The CPU bound spend more time doing computation and less time using what? Input and output device. And that's one of the disadvantages of this. The other question was asking, explain 2 disadvantages of FAT32 file system. What are the disadvantages of FAT32? One of the disadvantages of FAT32 is that the boot sector is not backed up. The boot sector is not backed up. Again, when you're dealing with FAT32, the storage is not accessible from other operating systems other than Windows 95 and 98. And that was a challenge. And then there is no compression. There is no file security. And then your storage cannot go over 32 GB. That was a disadvantage. FAT32, you remember 32 GB maximum. Your storage or the volume cannot go beyond what? More than 32 GB. The other question, remember all these questions for the craft, they are 4 marks, yeah? The first 10 questions are 4 marks, 4 marks, 4 marks, 4 marks, making 40. That is section A. Section B is 60 marks. You're supposed to do 3 questions of 15 marks, 15 marks. Outline 4 advantages of using multiprocessor system. What are the advantages of having multiprocessor system? Where you have more than one processor. What are the advantages? What are the benefits of having more than one processor? There is increased throughput. There is increased reliability. There is economy of scale. Multiprocessor system will cost less than when you're buying a single processor. Yeah, those are the advantages of that. Other question was asking about explain circumstance where short jobs fast scheduling algorithm could be applied in process management. Explain a circumstance where short jobs fast scheduling algorithm could be applied in process management. Short jobs fast. When can we use short jobs fast? Short jobs fast. Of course, is when you have when there is need to minimize the average response time. When there is need to minimize the average response time. Priority is given to short jobs. Are we together?
We're together.
Okay, that's fine. Now, so those are the circumstances that you can go for short jobs fast. When you want to minimize the average response time. Explain 4 functions of operating system memory manager. What is the function of the memory manager? Memory manager. We said memory is a scarce resource. So this memory has a manager that we are calling the memory manager. What is the function of this memory manager? Memory is a scarce resource. Why do we need a memory manager? In our day-to-day life, we have managers. Now we are managing memory. Why do we need a memory manager for memory management? To enable different processes to execute at the same time, yeah? Again, you have to protect processes from each other. Enable sharing of memory and making memory as transparent as possible. That is very important. Yes? The next question, explain the function of each of the following utility programs. Now, what is a utility program? It's a program that does a specific function. Yeah, that is what you call a utility program. Yeah, we have defragmenter, we have disk cleanup, we have even an antivirus, we have other programs that are utility. You can have a small program that just does backup. Yeah. Those are utility programs. Now, what is a disk defragmenter and what is disk cleanup? A disk defragmenter is a utility program that rearranges files and unused disk space to optimize operation. It is a utility program that rearranges files and unused disk space to optimize operation. That will mean, for example, if you have so many scattered files and so many holes in between, you bring all those related files together and then you have the free space on one end. So they rearrange files and unused disk spaces to optimize operation, thereby eliminating unnecessary fragmentation. Are we together? That is why it is called a defragmenter. Disk cleanup. We've all done cleanup even in our mobile phones, yeah? It's a troubleshooting utility or a program that identifies and eliminates non-essential files. Like in our mobile phone, we have a disk cleanup that will identify photos that you have never accessed for the last 3 months. And then it will ask you, these files have not been accessed for the last 3 months. Do you want to delete them? It will clean up the disk for you. It will delete those files for you. Are we together? Next question. I don't know how you see this paper, but mostly the craft papers are more difficult than the diploma. Explain the following terms as applied in process communication. What is a pipe and what is a deadlock? A pipe is basically a way of is a communication technique for passing information from one program to another. You want to pass information from one program to another. That's why it calls a pipe. A deadlock is a process where processes are competing for the same resource. The resource is not available for each other. We also said that it is a situation where processes are effectively preventing each other from accessing an unshareable resource. You remember? Yes, and I think those ones we discussed at deadlock. It's a situation where processes are effectively preventing each other from accessing an unshareable resource. And I think we talked about that. The other question, we said, question 7, explain 2 examples of computer terminals as used in computer system. And I think we discussed about this. We have dump terminals, we have intelligent terminals. Yeah, we have different types of terminals. Dump, we have intelligent, we have what you call a text terminal. These are the types of terminal. Dump terminal, it cannot interpret. So it can interpret limited number of controls. Intelligent terminal, it has its own processor. A text terminal, it is a serial computer interface for text entry and display. So you're only entering text and displaying text. Intelligent terminal, it has its own processor. Dump terminal can only interpret a limited number of codes, but does not have ability to process different things. So those are the 3 types of terminal. We have dump, we have intelligent, and we have a text terminal. Okay, the next question. Distinguish between physical and logical address applied in memory management. We discussed about this. What are the physical memory and what is a logical memory? Yes? Physical memory. Logical address is the address generated by the CPU. What about physical address? It is the address available on a memory unit or on a memory chip. Yeah. So you'll find that it's the address in a memory chip or in a memory unit. Either way. The other question is asking us to differentiate between internal and external fragmentation. You remember internal fragmentation occurs in fixed partition. You remember? External fragmentation occurs in dynamic partition. Those are very, very important statements as you begin. So we said external fragmentation. It occurs in dynamic allocation, where memory is fragmented, or where we are saying that where memory space is enough to satisfy a request, but it is not contiguous. It is fragmented in different locations of memory. But if the operating system or the processor decides to do compaction, then the memory would be enough to satisfy the request. So we are saying external fragmentation occurs in dynamic memory allocation. The total memory space could be enough to satisfy the request to a process that is in a secondary memory, but the memory is not contiguous. Internal fragmentation occurs in fixed partition, where the unused space cannot be allocated to another process. Internal fragmentation occurs in fixed memory allocation, where the unused space cannot be allocated to any other process. It cannot be allocated to any other process. 10 examples of operating system in the market today. I think that one you know. Yeah, starting from the Android to Windows 10 to Linux, yeah, to iOS and many others. Explain the concept of context switch as applied in process management. Context switching or context switch. Yes? Context switch. So when we talk about context switching, is a mechanism that enables processes to be restored in the PCB or process control block, so that a process that is executing can resume from the same point at a later point in time. That is what you call context switching, where you're removing a process from memory and placing it out in secondary memory. And when that particular process is brought back, it starts executing from the same point where it was suspended. So we are saying here that it's a mechanism that enables processes to be restored in the process control block, so that the process execution can be resumed at the same point at a later time. So when you're doing context switching, you're saying here that when the processor is suspended from execution and it handles another process, the CPU will come back and start executing from where it started. When you look at the William Starling textbook, for example, he uses the concept of somebody reading a book, and you have a bookmark and the phone rings. So once the phone rings, you place the bookmark where you had reached reading, and then you attend the phone or the phone call. Once the phone call is over, you go back and open your bookmark and continue reading. That's more of what you're saying. So it's a mechanism that enables processes to be restored. And you all know what is the process control block. It's basically giving you the status of a particular process, so that when the process is suspended, the CPU will start executing from that particular point where it is stopped. So it's a mechanism that enables processes to be restored in a PCB, so that process execution can be resumed at the same point at a time later. The other question that was the first compulsory questions. The other questions are optional. I don't know whether we'll be able to finish all of them today, but let's see. Question 11, list 6 examples of navigation keys in a QWERTY keyboard. We all know what are the navigation keys, yeah? For example, you have your keyboard, the arrow keys, up, down, and sideways, yeah? Those are navigation keys. We have page up, page down. We have home, we have end. Good that we have our keyboard here. These are the navigation keys. There are many. And for the arrows, you can have the up, down, left, right, home, end, page down. And I think we have them in our keyboard. The other question B was asking about through the intent to assign a file attribute to a file in a database. Explain the 3 attributes that she could assign to the file. We talked about the various types of attributes. Yeah, either it is read-only, that is for R or positive R. We talked about positive O, which is so we have A is archive, R read-only, S we have system, and I think there are a number of those attributes that we know. Yeah, so you could have either archive, you can have read, you can have hidden, you can have a system, you can have read-only. And mostly when you're dealing in those commands, you will be talking about positive A or negative A. Positive H for hide or negative H for unhide. It could be S for system or positive or negative S for removing a particular file from becoming a system. Or it could be positive R for read-only, or it could be R or negative R for negating now the aspect of read-only. So those are the attributes that you will get. The archive, you're indicating that that particular file has been saved for future reference. Hidden, you don't want people to view it. Indicate that the hosting file is not shown by default. When you say a system, you make an attribute of a particular file to be system, it indicates that the hosting file is not shown by default. That is for the hidden. For the system, you're indicating that the system is a critical system file that is very critical or very necessary for the operation of the computer. Read-only means that that file cannot be altered. It cannot be modified. It cannot be changed. So those are the attributes that you will find. So let's look at the other question. Is asking about what? Operating system apply different ways in order to improve disk performance. What are the 3 ways that you can employ to improve disk performance? Number 1, you remember what we were discussing about RAID? It's one of them. You can do RAID, where you have a battery of disks, either 2 or 3, then you will improve the performance. You can do what you call disk caching, where you have a temporary storage between your CPU and the main memory, and between your main memory. How are we organizing it? We had the memory disk caching, where you have a temporary storage that will allow fast access for data between the CPU and the memory. The information that is needed is stored in the cache memory. Yeah. Or you can do what you call I'm confusing between the cache memory and disk caching. So disk caching is a technology that basically uses faster but small memory type to accelerate the access for data. So you can do disk caching, you can do file compression or decompressing. What can you do to improve your disk performance? You can do cleanup. You can run the disk defragmenter tool that we discussed. Remember, we talked about the defragmenter. Yeah. So if you defragment your files, where your scattered files are brought together and the empty space is consecutive or contiguous, then you will improve the disk performance. You could also do disk cleanup, the one that we've just discussed a while ago. So those are the methods that you can do to improve the disk performance. The other question is asking about what? I think we'll only do question 12. God willing, we'll finish the rest. Outline 4 file management operation. Outline 4 file management operation of the operating system. If you're told to outline, it's more like listing. You don't explain. You don't waste time. So what are the 4 file management operations that an operating system can do? File management operation. So we have different file operations that can be done. You can create, you can delete, you can load a file, you can do backup, you can do mapping of files into secondary memory. You can even do directory creation. There are various file managements that can be done to particular files. So those are the 4 file management operations that can be done by the operating system. Distinguish between short-term scheduling and long-term scheduling, and medium-term scheduling for that matter, because they come hand in hand. You have short-term, you have medium-term, you have long-term. The short-term makes a decision on which process to admit. Remember, we discussed about that. For the medium term, it makes a decision on which process to run, on which process to access the CPU. But on long term, it makes a decision on which process to suspend or temporarily remove from execution. So short term, admitting. Medium term, making a decision on which process to access the CPU. long term, making a decision on which process to suspend from execution. And I think we discussed those in our previous in our last notes. The other question is asking about Joe found the computer in the computer room. Let me see whether I can increase the magnification a bit so that you're able to see. Joe found a computer in the computer room that had only the operating system installed on it. Outline 4 accessories of the operating system that he could use. When you have an operating system that does not have the application programs, what can you do with that computer that has only operating system and nothing more? It does not have the office suite. What can you do? Yes. Of course, the paint will be there, the calculator, the word pad, games will be there, the snipping tools, the sticky notes. Yeah. The paint will be there. So all those will be there. They come with the operating system, the paint, the calculator, the games, the sticky notes. The sticky notes are those like they normally come. You find them at the status band. You can drag them and make a quick note, and you don't need to save them because they are already there. They are sticky. They are there. It's not like a Word document where you have to save. For example, somebody is telling you, what is your mobile number? You don't have to waste a lot of time. You'll just open the sticky notes, and there you are, without any trouble. Describe interface metaphor as used in operating system, giving 4 examples of this interface metaphor. Interface metaphor. So we're saying an interface metaphor is a set of user interface, visuals, actions, and procedures. So we're saying here that an interface metaphor is a set of user interface visuals, actions, and procedures that will exploit specific knowledge. For example, if you look at the recycle bin, or maybe a folder, or maybe the icons that we normally use are what we refer to as the interface metaphor. For example, let me just go to my desktop. There are certain icons that are standard, yeah. Like for example, the browser. If you look at the browser, for example, if I'm using the Google Chrome, it has a specific symbol. Firefox, it has a specific symbol. The recycle bin has a specific symbol. The Zoom has a specific symbol. The Telegram has a specific symbol. Microsoft Teams has a specific symbol. Now, those are what you're calling the interface metaphor. For example, you have in your mobile phone, if I was to go to my mobile phone, there are those interface metaphor. For example, I go to my computer, I have the Gmail, I have file manager, the camera is an interface metaphor. If you look at messages, Facebook has its own metaphor. That's what we're calling the interface metaphor. So we are saying these interface metaphor, they are very important because they are user interface, they are visuals, they are actions and procedures that will basically exploit a specific knowledge that user already have of other domains. And examples of these are many, yeah, like my computer, my document, recycle bin, you can name them. These are interface metaphor. Now, the moment you see those icons, you relate them with something. You can never confuse a symbol for Instagram with that of Facebook. Whenever you see an F, you automatically know that is Facebook. Yeah. Or even the icons for the Windows Explorer, it is very specific. Or even mails, yeah, it is very, very specific. Even for Microsoft Word, the interface metaphor is very clear. You cannot confuse. So we're saying here that interface metaphor is their set of user interface, what you call visuals, yeah, or actions, or they can be procedures that exploit specific knowledge, yeah. So the moment you see that particular icon or that interface metaphor, you automatically relate it with something. For example, when you find in the icon for the text message, The moment you see 2, or maybe you see 1, your mind will automatically communicate and say, I have a message that I have not read. If it is in your Gmail, that interface metaphor for your Gmail, the moment you see it has 3, or it has 1, or it has 10, you'll automatically know I have 10 emails that I have not read. That is where we are saying that they exploit specific knowledge. So that icon or that interface will automatically tell you there is something. And that is what you call an interface metaphor. They're very powerful in communication. Very, very powerful in communication. Are we together? Now, question 13, talking about maskable and non-maskable interrupts. I think we discussed about them, yeah? What is the difference between maskable and non-maskable interrupts? Maskable interrupts can be ignored. Non-maskable interrupts are the types of interrupts that cannot be ignored. Are we together? Job intended to compile report on the computer visual display unit. Outline 4 examples that he could have included in the report. Visual display units. Types of screens. You've done them in ICT and ethics, yeah? We have the CRTs, we have the LCDs, we have electroluminescent, we have plasma, we have the TFTs, there are many. I think those ones you've done them in ICT and ethics. Examples, explain the following file path. Giving an example, yeah? We have relative path and absolute path. What is the difference between relative and absolute path? Absolute path, you're giving the full direction where a particular file is located. That is what we call the absolute. You're giving the full name of the file, including the source and its location. For example, if you go to your DOS command, yeah, you go to the DOS command, you're able to see the exact location. You're saying with what you're referring to as absolute. You're giving the direction. You're giving the full path. That is what you call the absolute path. Yeah, you're giving the full path or the full direction to where a particular file is found. For example, I don't know whether I can be able to open a Word document here, where you are saying maybe a file is in C, full colon. For example, if I was to maximize this and I'm giving the full path, for example, I will come here and say maybe C, full colon, backslash. I've really struggled to look for backslash in this new laptop. I don't know, I cannot be able to trace the backslash. Basically, when you're giving the full path, it will be C, maybe documents, or C, maybe Windows, backslash. And I can't see the backslash. It's supposed to be the backslash, but now I can't see the backslash. So you're supposed to, okay, I've seen it. Let me see. Yeah, it's there. It's there. It's supposed to be C backslash, maybe Windows, and then backslash, maybe exam, backslash, maybe os.doc. So you're saying that go to C, Windows, then in the Windows folder, there is exam folder. Then in the exam folder, there is the OS, which is a document file. That is the full path, or what we're talking about the absolute path. But when you're talking about the relative path, you can just say maybe you will come here and say if it is relative. Oh, sorry, should have said B or C. That is absolute. Relative will be, maybe you will say exam backslash os.doc. We are saying that it is in the folder called exam in a document called, and the document is called .doc. Put together. That is relative. Absolute, you're giving full path from the root directory of C, the first folder, the second folder, if you have the third folder, you give, and then the file name. For the relative, you're only showing the the path where that particular file will be found. So you don't disclose the entire path to where that particular file is found. Are we together? Let me share the other window. What is the scheduling algorithm that is shown below? What is this? So what scheduling algorithm is this? You can comment in the chat section. Now, this kind of question is very tricky because you fail at 1. I don't need to mark part 2. For example, if somebody says it is short jobs first, and maybe it is wrong, I don't need to mark the second one, whether it is right or not. So the moment you miss part 1 of this question, then part 2 automatically is a 0. So we're saying this is round robin, but what are the advantages of round robin here? Of course, we discussed about this. One of the advantages, there is fairness because you're giving each process equal time slice. And that becomes a very big advantage. Yes, there's fairness. Again, the chances of starvation are minimal. There is no provision for starvation or where processes wait for a very long time in the queue because each process is given a time slice. I think we'll stop there. God willing, we'll be able to continue from question 14. I think we are done with question 13. So we'll do question 14 and 15. And then see whether we can get the question paper for November, for March 2020 series.
Reduce starvation.
Yes. Come again. We said in round robin there is no starvation, and that becomes a big advantage. Yeah, it's a big advantage for the same. With those many remarks, wish you well. We meet again in the next lesson. Enjoy your week.